When I talk to people about artificial intelligence, I consistently get two impressions. That's amazing, and that's scary. And in fact, it's both. We're going to talk about that today in the BOCOTALKS Chamber of Commerce speaking series called BOCOTALKS, sponsored by Member One. I'm Robert Turcotte, and I am with Entre Computer Center. This is Kathy Wood. She's a top tech investor, and she says that artificial intelligence should increase productivity in the office by fourfold as quickly as 2030. Despite all the optimism around artificial intelligence, there also are cautions, and we're going to talk about that as well. The portion of artificial intelligence that we're talking about is natural language processing. And that's a portion of the artificial intelligence world. And essentially, it's that the computer is talking back to you as though it were a human. Now, I'm here to make a prediction, a bold one. And in a few years, we'll know if I'm a genius or a goat. I say that natural language processing is more impactful in the future than the three pillars of modern computing: the 1981 introduction of the IBM PC, the World Wide Web, and the Internet, and the smartphone. Natural language processing has huge potential, and we're going to look at the three pieces that make up natural language processing and see, in fact, if those technologies can contribute in a way that bring us along and make Kathy Wood's prediction come true. First, we'll look at human language. And I ask you a question here, and that is, have you ever been talking to another person? You think that you are clearly communicating, and you look at them, and what you see on their face is a question mark. It's happened to all of us. And in fact, it should be easy to us. We've been communicating with each other since a very early age and continuously through our lives. The point here is, as difficult as it is for us, it's even more difficult for a computer. The second piece we're going to look at is artificial intelligence, and in particular, how it feels when a computer talks back to you and you think a person is on the other side because it seems sentient. Alan Turing, the father of artificial intelligence, the start of which dates back to the 1940s, came up with the Turing test. And that is indeed that you are communicating with a computer, and when that computer responds, it's like a human was on the other side of that conversation. The second portion we're going to look at is the computer science. To process natural language processing takes huge amounts of computing power. And the question is, can this keep up? Alan Turing shows up again in the Turing Complete computer. And that is a computer that can solve any problem given enough time. Those experiments go back to the ENIAC in the 1940s. We've come a long way since then. We still have a long way to go. And the last piece is that all three of these pieces go together to make natural language processing progress. Let's look at human language first. The current leader in natural language processing is ChatGPT. It is a partnership between Microsoft and OpenAI, a nonprofit, and you can go to that site and start to use ChatGPT at openai.com. The other competitor that's one of the biggest is Google Bard. Google got a late start. And in fact, we know that this is a big, smart, and well-financed company. We expect that they will catch up. You can access their capability at bard.google.com. A caution here And that is, when you go to these sites, don't go to a search bar and search for ChatGPT or Google Bard. Go directly to openai.com, bard.google.com. And the reason is, if you search, you're going to get people links to go to sites that are trying to make money on top of those capabilities. Now, this is a list of the things that artificial intelligence and natural language processing does extremely well. I'm going to concentrate on the first one while you look through the list. At our company, I had heard that ChatGPT is fantastic at writing programs. Now, I'm not very good at writing programs. In fact, I haven't done it in 20 or 25 years. It's not satisfying to me. I went to one of our technicians and said, I would like to write a script, a program, that will control a Microsoft server. Give me 4 things that this script should say. And he gave me 4 points. I went to my computer keyboard and said, write a basic A script that, drop the 4 points in, and when I touched the enter key, within seconds, I had a program. Took it down to my technician. He read it and looked up and said, that's it. Hey people, ChatGPT and I can write computer programs. Now, I humbly say, don't ask me to load it and run it because I have no idea how to do that. Here's another caution. Natural language processing at times hallucinates. That is, it gives you answers that sound perfectly plausible, but are wrong. An example is an attorney recently wrote a brief, sent it to a judge, and all of the cases cited in the brief didn't exist. Pure fiction. The judge dismissed the case. Check your facts all the time. Consider the work done by natural language processing to be a good first draft. Let's look at the artificial intelligence piece. In this piece, it gets a little technical, and if you're not that technical, that's okay. Just listen for conceptual content. Microsoft is so enamored with OpenAI and ChatGPT that they're going to build that capability into every product they sell. And not only that, it's going so fast that the folks at Google say that the scope of what can be done in AI doubles every 6 months. It's incredibly fast. And here in pictures is an example of how we're progressing. In 2018, AI could produce that little tiny picture to your left. It's not very clear. It's hard to look at because it's so small. By 2022, the bird is much better defined, still a little blurry, there's no background, and it doesn't look real. 1 year later, in 2023, we can produce easily the picture that you see on your right. With a wonderful background, the bird looks sharp. I'm not sure about that beak. That might be a hallucination. However, we can see that the capabilities are coming along incredibly fast. Here's where it gets a little technical. We have been operating with specific models in artificial intelligence for some time. These specific models can do image or text or speech, but not all at the same time. And if you don't think that you've been using AI, if you have a phone, the battery life is maximized by the manufacturer using artificial intelligence. Whether you know it or not, you've been using it. We progress through time, and now we go to the general model. And that's what started to happen at the end of 2022 when ChatGPT came on the scene. ChatGPT is a general model AI, and it can do image and text and speech at the same time. And here's a key point. It self-learns. It gets better on its own without human interaction. And that's why we're progressing so quickly right now. Let's look at an example from the New York Times. The New York Times has a research and development arm, and they're taking a database of their stories and asking artificial intelligence, have we missed anything? Can we take 2 headlines and combine those into a story that we have not thought of? And here's how they do it. On the left is the specific model. It's a hard word. And you notice in the box to your left that contains the circles, that is your training data. We're going to use medical imaging as an example of how this works. We take, in the medical arena, the images that we take of folks, x-rays, PET scans, and so forth, and we drop those into a very specialized database. We also take the radiologist's report, the typed report, and we drop that in there. And over time, we build this database. Now, when a new image comes in and the radiologist's report, the AI can review it and say, yes, that looks great, or could you have missed something that looks like a kidney stone? This is amazing, and it's been going on for some time. The interesting point here is that compiling these databases, writing the AI, and so forth in those specific models is very time-consuming and very expensive. In the world of medicine, people's lives are at stake, and we can do that. Now, the New York Times is using a general model. You still see the database with the circles in it. Not only can we use our database in this example, but we can take databases from other sources, other hospitals, for instance, and combine them. The bigger database is going to give you better results. When we're experimenting with this, we know that we have a high capability here because we're using natural language processing that self-learns. Those bigger databases are going to give better results and more accurate results in the analysis of these images. So from the specific model to the general model, we've come a long way, and we've got a long way to go. There are some concerns, especially about HIPAA privacy. Sometimes we need to put guardrails on these capabilities, and we're working on it. And you might have noticed that the OpenAI founder has been in front of Congress lately because our legislators know that they need guardrails on this technology to make it as safe as we can. Let's look at the computer science because it takes huge amounts of computing power to push along these results. Evidence of that is that ChatGPT at Microsoft costs $700,000 every single day to power that artificial intelligence. This is one module from the most powerful computer on Earth. And I show it for a couple of reasons. One, with a human beside it so you can see the scale. And two, notice that one of the groups that is involved is Hewlett-Packard. And here's the computer built out. It costs $600 million to make. It's at Oak Ridge in Tennessee, and it does nuclear weapons research. It's huge. And not only is it on that one floor, but in the floor above, you have cooling that's pushed down to keep this room cool. And from below, power. 3 giant floors of computing. And this computer operates at an exaflop. So let's break that down. A flop is 1 cycle in a computer. And it does that a quintillion times every second second after second. An amazingly fast computer. Now, the top500.org for 30 years has ranked the fastest computers on Earth. You'll see that Frontier is rated at the top, and they were just rated at 1.2 exaflops. To show how exceptional this computer is, by the time you get to number 4, you're at 0.24 exaflops. In the 30 years or so that I've watched this list, I don't think I've ever seen this kind of disparity in the top 10. So what does it take to get into the future to push along these calculations in a way that is meaningful? Well, along comes a company that nobody's ever heard of, Cerebras. And these guys did something absolutely genius. They've come up, here's a module from their computer and a portion of their computer, a mere $35 million for an exaflop machine. Amazing. Not only are they able to make the computer smaller, use less cooling, less power, a more flexible computer, but they've dropped the price dramatically. And here's how they do it. The chip on the right is about this big, and it's the size of the computer, the chip in the computer that you own. The Cerebras chip is to the left, and it is enormous. Many groups have tried to make this chip this big, and they've all failed until Cerebras did it. What happens in this chip? You have a lot of cores, and you don't have to go off of this chip to do your processing, and it makes it very, very fast. It's huge. It's absolutely amazing. So HPE has said that they're going to make the next fastest computer. And if you look at the last full line here, look who their partner is, Cerebras. It's highly likely that they're going to be able to do this. And then comes along Tesla. Within the past few weeks, they have fired up Dojo, their computer that is going to do self-driving analysis and hopefully make their full self-driving dream come true. And look at this chart. Shortly, it will be a 1 exaflop machine, and they say that by the end of 2024, they will be processing not at 1 exaflop, but 100 exaflops. Amazing. NVIDIA makes a lot of the chips that are in these supercomputers, and they say in 10 years we'll have 1 million times the capability we have today. So it's highly likely that we'll be able to process all of this natural language processing. From ENIAC in the 1940s to the frontier of now, we've come a long way, and it's obvious to me that we have a lot of headroom. So in fact, to process natural language processing, the human language piece is coming along amazingly well. The self-learning capabilities of the artificial intelligence are ensuring it, and it appears that the computer science is going to be in place, and natural language processing will go quickly along. Let's look at another open AI product, and we'll look at several examples of how AI is used. DALL-E 2 is the image processing capability from OpenAI and Microsoft. And I sat down and logged into DALL-E 2 one evening, and within 10 minutes, I made a dog with a surprised look on its face, and with a human with a surprised look on its face, and on a train, and at a concert. Just like I'm not a programmer, I'm not an artist. But all of a sudden, I can make pretty good-looking graphics using DALL-E 2. Microsoft is going to combine ChatGPT and DALL-E capabilities into Microsoft Designer. It is a Canva-like piece of software. You'll be able to make posters and trifold brochures and all of that very easily. The early reports coming out of the testing of this are amazing. Let's look at societal impacts. Where are we going to see the most impact? Well, in computer programming, we've already said that OpenAI and computer programming go together. You can drop an old COBOL program into ChatGPT and it will document it for you. Or you can say, take this COBOL program and make it a Java program, and it will do it for you. Legal functions, it looks like about 40% of everything that happens in a legal firm can be replaced by AI. Especially at risk is the paralegal, and it appears that a lot of the work paralegals do will be replaced. And then where are we going to see the most impacts? Well, educators jumped out in a hurry in the beginning and said, the sky's falling. And now they're saying, well, you know, I think we can live with this. They've learned how to educate in a way that embraces AI. And a friend of mine spent the entire summer AI proofing her classes for this year. Here's a fellow who had a wife who wanted a certain portion of her website to be automated. He's a programmer, and he said I could have done that in a day to a day and a half. He wrote it in 5 minutes with ChatGPT's help, and it ran the first time. There's the code. 2 guys, 136-page magazine in 5 days. Unbelievable and true. You can't do that without help. And then in April, it is said that half the gains in the stock market this year are directly attributable to ChatGPT's help. Up next, I think, is ambient computing. Anyone who talks to their phone knows that it's a great assistant, but at times it can be dumb as a box of rocks. Apple is spending about $1 million a day developing artificial intelligence. You can bet that it's going to be in their phones. Amazon has already been delivering artificial intelligence for some time, and we can bet that their smart speakers, again, can be dumb as rocks, will get even more intelligence now. Here's one of the main points. Treat ChatGPT and natural language processing like it's a child. If you ask a big, broad question, you're going to get a big, broad answer. If you want a meaningful answer, the prompt should have very specific instructions about what you want the natural language processing engine to consider. And then you'll get great results. Well, in a few years, when you see me on the street, I'll be a hero and a genius or a goat, because I think natural language processing is going to overturn the world. You're not going to be able to hide from it. The pieces are indeed in place for natural language processing to take off. It's here. You can't hide from it. From the BOCOTALKS chamber and member 1, here it comes.